So we're going to look at an example here of a function and its derivative and how that relates to us, whether the function's increasing or decreasing on the graph. So here's a pretty basic function. It's a quadratic function, a parabola. F of x equals x squared minus 2x. And over here you can see the graph. But one of the ideas we're kind of working towards in this section is that by looking at the function's formula first and analyzing the derivative and some other information about the function, we can better draw the graph because the derivative tells us a lot about what the graph's going to look like. So kind of imagine for a moment that we don't have this graph yet, and we could kind of look at it on the calculator or graph it by hand as we would have in college algebra. But we want to go to the function first and see what we can learn about the graph before we see it. Okay. So if you look at the derivative of this function, it's a pretty simple function. The derivative is just going to be 2x minus 2. Okay. Well, the idea with the derivative is, the derivative tells us the slope of the function. So if we want to know when this function is increasing, so when is the function increasing? Okay. Well, that happens exactly when the derivative is greater than 0. Okay. So we can actually see that just by figuring out when this is greater than 0. Now we'll talk about some shortcuts for doing this a little bit later, but this is a pretty easy function, this derivative 2x minus 2, just to set greater than 0 and solve for x. Just a basic little inequality. If I add 2 to both sides, I get 2x is greater than 2. I can divide both sides by 2, and I get x is greater than 1. Okay. So this function is increasing when x is greater than 1. Now another way of saying that is it's increasing on the interval of x values from 1 to infinity. Okay. For these x values, these are the x values bigger than 1, the function's increasing. Now if you go over and look at the graph, you'll see that. Okay. Right here is the x value of 1. Okay. Now look at what happens on our graph. Right here when x is 1, and our graph is at the point 1, negative 1, but right here at this point the function starts increasing. You see for all of the x coordinates bigger than 1, okay, our function is going to be moving up because that's when the derivative is positive. Okay. Now we see that our function does increase from 1 to infinity. In other words, for x values that are bigger than 1, it's increasing. But of course we can ask the similar question about when is our function decreasing. Of course that happens whenever the derivative is negative. So if you can tell me where the function has a negative derivative, we know the slope of the function is going to be negative, so the function is going to move down from left to right. Well, it's a very similar inequality. If I set 2x minus 2 less than 0, I can add 2 to both sides. I get 2x is less than 2 divided by 2. I get x is less than 1. Okay. So our function is decreasing for all x values less than 1. So we can say it's decreasing on the interval negative infinity to 1. Okay, now remember, this interval is just the x coordinates where our function is decreasing. So what does that mean? Decreasing from negative infinity to 1. Well, it means that for these x coordinates, okay, the ones that are all the way to the left on the x-axis, up until 1, the function will be decreasing. And of course you see that on the graph. The graph is moving down from left to right. Now of course the change occurs right here. Okay, the function's decreasing, okay, from negative infinity to 1, okay, and then from 1 to infinity the function's increasing. So what happens right here when x is equal to 1? Okay. Well, when the derivative is equal to 0, it's neither increasing nor decreasing. So if we set 2x minus 2 equal to 0, of course you'll see that happens when x is equal to 1. So the thing to notice at this point is those points where the derivative is actually equal to 0, or in fact it also turns out when the derivative is undefined, the function really isn't increasing or decreasing. It can be doing kind of nothing really. It's sort of changing between increasing and decreasing in this case.